Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Well, welcome back to our machine learning class. In this class, we move on to recommendation algorithm. And this course, we primarily introduced two recommendation system algorithms and their corresponding case studies. Firstly, let's take a look at Amazon. You might be surprised to learn that a whopping 35% of their sales actually come from recommendations. This is basically their system suggesting products that you might like based on what you've previously bought or browsed. So, if you've never wondered why you end up buying more than you intended from Amazon, here's your answer. Jeff Bezos, the founder of Amazon, once said something really interesting. He mentioned, if I have 1,000,000 users, I will make 1,000,000 different websites. This essentially means that he wants to personalize the shopping experience for every single user. It's not about creating one size fit or opposite, but rather 1,000,000 tailor-made ones. Now, moving on to Netflix. Did you know that 75% of what people watch on Netflix is based on reviews from their recommendation system?
This shows just how effective their algorithm is at predicting
and suggesting what you might like to watch next. So, in essence, recommendation algorithms play a vital role
in the success of these internet giants.
They help personalize the user's experience, which in turn drives more engagement and sales. On social networking site, one common practice is to suggest potential connections to users. For instance, the platform may recommend individuals that a user might be interested in connecting with or following based on their shared interests or mutual friends. Another aspect of social-based recommendations involves something known as a social graph. This uses a user's preference to recommend a variety of things to their friends. This could be anything from other people and groups to specific content, products, and so on. Now, when it comes to non-social networking sites, they may have a different approach.
They often make use of API from social networking sites
to gain insight into users' social circles preference. By doing so, they can make educated suggestions about the user's own interest and preference. Additionally, these non-social networking sites also use the same social networking site APIs to directly understand the individual user's preference, providing an even more personalized recommendation experience. In our daily lives, we often come across applications of recommendation systems. For example, product recommendations on e-commerce platforms, movie recommendations, news recommendations, music recommendations, and more. There are even more advanced applications such as social media platforms recommendation content that your friends might be interested in, suggesting people you might know and providing location-based recommendations for previous types of content. Now we're going to learn about the algorithms used in recommendation systems, starting with collaborative filtering.
Collaborative filtering is primarily
used to handle situations where users' preferences are unclear. It's similar to when we search for something and often cannot accurately describe our query.
This method helps us quickly and accurately identify the information we need. When applying collaborative filtering, we assume that
If two entities exhibit similar behavior, their preferences are likely to be similar as well. Collaborative filtering is based on calculating the similarities between entities to make recommendations. The next things we learn is how to calculate the similarity between entities. The measure of similarity is often expressed using other concepts called distance. If we construct a feature space using the various attributes of entities, entities that are physically closer in space are considered more similar. There are multiple ways to define distance, and there are 6 common distance metrics. The cosine distance,
the Chebyshev distance, Euclidean distance, Pearson distance, Manhattan distance, and Shakar distance.
Each of these distance metrics has its own applicable scenarios and user cases.
The Euclidean distance is a measure of straight-line distance between 2 points in space.
It's one of the most common distance metrics used.
The formula to calculate the Euclidean
distance in 2-dimensional space between the points x1, y1 and x2, y2 is like this. This can be extended to n dimensions, summing up the square distance for each dimension and then taking the square root. It's basically
as the cross-file distance between 2 points.
If you imagine that you're drawing a line between these 2 points in your space,
the Euclidean distance would be the length of that line. Collaborative filtering is the most widely used recommendation method,
which focused on understanding the relationship between users and items rather than considering the properties of items themselves. It can be categorized to 2 types: the user-based collaborative filtering and item-based collaborative filtering.